This can be a pretty difficult question if you're doing this for the first time because it requires you to know the graphical representation of the wave equation, and you need to apply a little bit of what you have learned in math on how the graphs or equations look like. So the answer to this question is B, and the equation for this question that you can use is the wave equation. So V equals F lambda over here. I can just rewrite the wave equation using a constant value because after all the velocity of the EM waves is always kept constant. And if we decide to plot F against lambda, we can recognize that this is actually like an inverse relationship that you have learned in math. And that's why for any inverse relationship graphs, it always looks like this manner, and that's why the answer to this question is B. And this is something that you might want to memorize, that the graphs of frequency against lambda or wavelength against frequency, I mean the order doesn't quite matter, it's always it always takes the shape of this. One way to convince yourself is actually to look at the wave equation, and as the wavelength increases, which is over here, as the wavelength gets bigger and bigger, notice that the value of frequency actually drops to a very small value. So as wavelength increases, frequency should drop to a very small value. Now, extending this, there is another variant of the question that you might be asked, and that is over here. Now, using the same wave equation, if I choose to plot not frequency against wavelength, but rather frequency against 1 over wavelength, what type of graph should I get? You might want to pause the video to think of what type of graph will you get. All right, so if this is the vertical axis, y-axis, and we are plotting this instead of wavelength, we are plotting 1 over wavelength as x-axis on the horizontal axis, then this is the gradient of the graph, and you can notice that this becomes the equation of a straight line, and that is why this is another variant of the graph that represents the wave equation. If we plot frequency against 1 over wavelength, we will get a straight line that passes through the origin. Now, take some time to note this down and compare this graph with the answer over here. Both of these graphs are different graphs, but both of them represents the wave equation.